Here are our solutions for quiz 6 from Math 111. We're given this quadratic trinomial and asked a bunch of stuff about it. First asked to express it in this form, this vertex form, or this standard form as your homework calls it. So basically what I'm getting at here is complete the square so that this looks like this. So the way you can do that is, well, one way to do it is we're going to have to do a lot of algebra. I'm going to have to move pieces to both sides. So I kind of prefer this as a y instead of an f of x, just because I'll get confused if I write f of x over and over again. And now to complete the square, I need the x squared term and the x term to be all by themselves. So I'm going to add 10 to both sides of the equation. And furthermore, for our method of completing the square, I need the leading coefficient, the coefficient on my x squared term, to be positive 1. It's currently negative 2. So in order to make that positive 1, I'll have to divide both sides of the equation by negative 2. So y plus 10 divided by negative 2 is equal to 1x squared minus 6x. Note that 12 divided by negative 2 is negative 6x. So what you have here is actually good. Maybe I need to, I could squeeze it in. Now that we have the x squared term and the x term isolated, we can complete the square. So the way you complete the square is I have to add some number to both sides of the equation that will leave me with a perfect square on the right-hand side of the equation. What that number is in this case is positive 9. Where I got that positive 9 from is it's half of the coefficient on the x term here, so half of negative 6 is negative 3, squared is positive 9. So what I now have is positive 9 plus, hard to even read my own writing, start over. I got 9 plus y plus 10 divided by negative 2 is equal to, over here I got a perfect square. I have x minus 3 squared. If you have trouble seeing how this is x minus 3 squared, there's kind of a formulaic method of getting here. All you have to do is take that half of this coefficient. So this coefficient was negative 6. To get this 9, I cut it in half and squared it. To get what goes here, I just cut it in half. Half of negative 6 is negative 3. Anyways, I'm here, which is almost this form. All I got to do now is solve for y. So if I'm solving for y, the first thing I want to do is subtract 9 from both sides of the equation. That would give me y plus 10 divided by negative 2 is equal to x minus 3 squared minus 9. I subtracted 9 from both sides of the equation. Now I want to get rid of this negative 2. To get rid of that negative 2, I can multiply both sides of the equation by negative 2. If I multiply this side of the equation by negative 2, I have two terms over here. One of them is this x minus 3 squared term, and the other one is the negative 9. So negative 2 times negative 9 is positive 18. Multiply both sides of the equation by negative 2, you get here. And then finally subtract 10 from both sides of the equation. 18 minus 10 is just 8. So you get to here. This is equivalent to this. The only difference is down here I have it in this vertex form. Maybe instead of y equals, I should have put f of x equals, or y equals, I don't care. I think that just makes it look worse. So I'm going to leave it like this. Okay, why bother? Why do all that work? Well, now that we have it in this form, we can just look at this and tell where the vertex of this parabola is. So what's going on is this negative 2 flips my vertex upside down. This negative 3, the negative 2 flips the graph upside down and stretches it vertically. But it doesn't move the vertex at all. This negative 3 moves my vertex to the right by 3, and this positive 8 moves my vertex up by 8. What I'm saying is the vertex starts out at 0, 0, and then goes right 3 and up 8. So it ends up at the point 3, 8. Is this vertex a maximum or a minimum? This vertex is a maximum. How do I know that? Because this negative 2 right here, the negative in negative 2, flipped it. Maybe just flipped it, sure. It flips it vertically. It flips it over the x-axis. So you start out with our standard parabola, and then you flip it upside down, so now it looks like this. Then you move it all around. You move it up 8 and right 3. So you end up with something that looks like this. But the point is that it was flipped over, so the vertex is now a maximum. I'm going to erase that horrible picture. Determine the y-intercept of this parabola. The y-intercept happens, maybe happens when x equals 0. You don't need to write this, just explaining. So we go up to our original form here, and we make all the x's equal to 0. We get f of 0, which is equal to, 0 plus 0 minus 10. It's equal to negative 10. Determine the y-intercept of this parabola, negative 10. Or if you want 0 comma negative 10. However you want to write it, I don't care. Determine the x-intercepts of this parabola. That's a little bit harder. X-intercepts, those happen when y equals 0. And so the y is the f of x. In other words, this f of x here is equal to negative 2 times x minus 3 squared plus 8. Double check that I copied it all down right. If I make y equal to 0 and solve for x, I'll get the x-intercepts. So to solve this equation for x, I'll subtract 8 from both sides. No, I won't. You could do it that way. I'm going to add this term over to this side, keep things positive. I added this to the left. If you want, you could subtract the 8, get the same thing. Now I'll divide by 2. Now I'll take the square root of both sides of the equation. So I get x minus 3 equals plus or minus 2. So x is equal to 3 plus or minus 2. In other words, x equals 5 and x equals 1. If you want, you could express that as 5, 0, and 1, 0. I don't care which way you write it. Either way, totally fine. Those are our two x-intercepts. That's everything in problem 1. Problem 2. Given another parabola, although this time it's not a quadratic trinomial. Now we have a 4th degree parabola here. First thing, determine the end behavior. To figure out the end behavior, all you got to do is look at this first term, and the exponent is even, and the coefficient on it is negative. So what that means is it's going to go down when we go to the left and down when we go to the right. In other words, as x approaches infinity, y is going to approach negative infinity. When we go to the right, we go down. And as x approaches negative infinity, y approaches negative infinity. When we go to the left, we go down. Right, down, left, down. That's what this picture is saying. To get full credit, your answer should be written like this. If you leave it like this, maybe I'll even put minus 1 point if you just draw the picture. Fair enough. Determine the y-intercept of this parabola. Much like above, the y-intercepts happen when x equals 0. So all I got to do is change all the x's into zeros. I get 0 plus 0 plus 0. That's not a 0. Plus 0 minus 0, which is equal to 0. So my answer is just 0. Or if you want, it's at 0, 0. Determine the roots of this parabola, aka the x-intercepts, and their corresponding multiplicities. All right, the way you do that is we're going to take the equation, negative 2x to the 4th power, plus 4x cubed, plus 8x squared, minus 16x, set it equal to 0, and solve. We got 4 terms. Let's see, look for greatest common factor first. They all have an x in them. Actually, they all have a 2x in them. I can factor 2x out. I can factor negative 2x out if I really wanted my leading coefficient to be positive. That'll leave me with x cubed minus 2x squared minus 4x plus 8 equals 0. Then I could factor inside the parentheses. If I factor by grouping, you know what? I'm going to write this a little bit differently. So I got something times something equals 0. Either negative 2x equals 0 or x cubed minus 2x squared minus 4x plus 8 equals 0. So if you divide both sides by negative 2, we get x equals 0 over here. To determine the solutions to this equation, I'll have to do some work. I'll have to factor by grouping. Look at these first two terms. They both have an x squared in common. So I'll factor that out and be left with x minus 2. If I want to be left with x minus 2 over here, I'll have to factor out a negative 4. So what I get is I have two terms and they both have an x minus 2 in them. Pull out that x minus 2, and you got x squared minus 4. We can take this one step further. This is a difference of squares. It's x minus 2 times x plus 2. So either this equals 0, this equals 0, this equals 0. Can I squeeze that in? Either x minus 2 equals 0, x minus 2 equals 0, or x plus 2 equals 0. So either x equals 2 or x equals negative 2. So I got X-intercepts. I got one at x equals 0, one at x equals 2, and one at x equals negative 2. And this one has multiplicity of 1. This has a multiplicity of 2. This one showed up twice. And this has a multiplicity of 1. All right, that's the roots of the parabola, aka the x-intercepts, and their corresponding multiplicities. Sketch an approximate graph of the parabola. It's not a parabola, damn, of the polynomial. Wonder if I screwed that up anywhere else. Yep. Polynomial. Hope that didn't screw anybody up. Sketch an approximate graph of the polynomial, making sure to include your answers to parts A through C above. What I'm saying is draw a picture and make sure it illustrates all this stuff. Make sure it's going down on both sides. Make sure it's got a y-intercept of 0, so it goes through this point right here. And make sure it's got x-intercepts at 0, 2, and negative 2. So there's 2, there's negative 2. Make sure it goes through this point and this point. And furthermore, that the multiplicity on this root is even, so it's going to bounce here, but go through the graph here and here. And if you look up at part A, it says the end behavior. It's going to go down on both sides. So what this thing has got to look like is it's got to go through here, turn around, bounce off, and go down. Looks something like this. Doesn't have to look exactly like this. For example, you don't know how high up it goes right where I'm drawing now. We don't know how steep this is here. There's a lot of things we don't know that we'll have to take a calculus class to figure out. Make sure it goes through these 3 points and then it bounces off here. And you got the end behavior right. That's everything I want. So that's the end of this quiz.